Overnight, your host CPU hits 100%. You find a container called System Monitor eating 98% CPU. You kill it, and a new one appears. Kill that, another pops up. This isn't a Docker bug. It's an attacker who exploited a mounted Docker socket to run a Cryptominer. Here's exactly why. Welcome to TheCodeForge. Before we dig into that production issue, let's cover Docker security best practices. Docker security is about protecting the host kernel from container escapes, limiting the blast radius of a compromise, securing the image supply chain, and monitoring runtime behavior for anomalies. Each layer builds on the previous one. Docker containers run as root by default. If a container escapes, the attacker gets root on the host. Running as a non-root user limits the damage. Even after escape, the process runs as an unprivileged user. Here's a secure Dockerfile. We perform all root operations first, then create a non-root user and switch to it. The user instruction must come before cmd or entrypont. Every dependency in your image is an attack surface. Scan both OS packages and language dependencies. Integrate scanning into CI and fail the build on critical CVEs. Generate an SBOM for rapid incident response. Here's how to scan an image with Trivy, generate an SBOM with Sift, and sign the image with cosign. The exit code 1 flag ensures CI fails if vulnerabilities are found. Secrets must never be baked into image layers. env, arg, and copy all exposed secrets permanently. Use build kits mount equals type equals secret for build time secrets and secrets managers for runtime. Here's how to use build kit secrets. The secret is mounted during build but never written to any layer. Build with Docker build kit equals 1 and secret ID equals pipey token, src equals $home/pipey token. Runtime hardening reduces the attack surface of a running container. Use read-only file systems, drop all capabilities, apply seccomp and AppArmor profiles, and set resource limits. Each layer adds negligible overhead. Here's a fully hardened run command. Read-only root file system, tmpfs for writable paths, all capabilities dropped except netbind service, seccomp and AppArmor profiles, and resource limits. The Docker daemon is the control plane. Expose it only with TLS and client certificates. Enable user namespace, remapping so container root maps to an unprivileged host user. Enable live restore and disable intercontainer communication. Here's a secure daemon, JSON configuration. It enables user namespace remapping, live restore, no new privileges, and TLS with client certificate authentication. The daemon listens on port 2376 with TLS required. This is the same issue we highlighted at the start. Here's exactly why that happened. A monitoring container had the Docker socket mounted. The attacker exploited an RCE vulnerability in node exporter, then used the socket to create a privileged container that mounted the host file system and installed a Cryptominer. The fix: remove the Docker socket mount and switch to cAdvisor, which doesn't need it. Rebuild all containers with user non-root. Enable daemon TLS and add Falco runtime security rules to alert on new container creation. Mounting the Docker socket gives the container root access to the host. If that container has an RCE, the attacker can create privileged containers and compromise the host. Never mount the socket unless absolutely necessary. Without the no new privileges flag, a non-root process can execute setuid binaries like sudo or ping to escalate to root. Always pair security opt equals no new privileges, true with a non-root user. If you forget the user instruction, the container runs as root. An RCE vulnerability then gives the attacker root access inside the container and potentially on the host. Scanning only application dependencies misses critical CVEs in the base OS. Use Trivy, which scans both OS packages and language dependencies in a single pass. Even if you delete a secret file in a later layer, it still exists in the earlier layer because layers are additive. Use BuildKit secrets instead. Rootless mode, introduced in Docker 19.03, requires Docker Rootless setup tool, SH, and has networking limitations. It does not support privileged, Capadd equals sysadmin, or most CNI plugins, e.g. Calico. Test your networking stack before switching, and never use userns equals host in a rootless setup. It defeats the entire point. The article mentions custom seccomp profiles, but does not show one. Below is a minimal custom profile that blocks mount and unshare syscalls for containers that do not need them, reducing the attack surface further than the default profile. Rootless mode is not just a nice-to-have. It is a critical defense against container escape vulnerabilities like CVE 2019-5736, runc breakout. By mapping container root to a non-root host user, even a successful escape yields only unprivileged access. This is especially important in multi-tenant environments where containers from different customers share a host. Here's a debugging guide. Check for socket mounts, audit container users, scan images for CVEs, and verify daemon TLS. These commands help you quickly identify security issues. Let's run through some common interview questions. Why is mounting var/run/docker sock dangerous? It gives root access to the host via the Docker API. How do you run a container as non-root? Add user instruction in Dockerfile and use security opt equals no new privileges. What is the purpose of seccomp? It filters syscalls to reduce kernel attack surface. And a few frequently asked questions. Can I use Docker secrets in Compose? Yes, use the secrets top-level element with file-based secrets. What is user namespace remapping? It maps container root to an unprivileged host user. How often should I scan images? Every build and weekly for running images. Key takeaways: never mount the Docker socket. Always run containers as non-root. Use read-only file systems, drop capabilities, scan images, sign them, and secure the daemon with TLS and user namespace remapping. Ready to go deeper? Up next, multi-stage Docker builds, then Docker Swarm basics, then optimizing Docker images. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.